Good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. And we're back. Now, what we're going to be talking about today has to do with some terminology that you will, it's hard to come across in other forms of life. I mean, these are things that people probably know instinctively, but I'm actually going to put terms to these things, okay? And you're going to see them play out here in a little bit. There are things in this chapter, guys, I'm just going to be honest with you. This chapter seems to kind of just throw a lot of things together and put it in a single chapter. And so you really need to pay attention to the terminology. Daily review the vocabulary. I don't think it's a hard chapter, but if you don't review your vocabulary daily, you're really going to struggle in this chapter. And so I'm really going to stress that. Know your vocabulary as we move forward. It's also a chapter, I'm just going to say this, that I find it's interesting. It's like, oh, that's cool. That's really cool how that all came together. I didn't know that would actually happen, you know? And so I'm going to try to show you these things, and then, you know, we're going to study it in this chapter, and in a couple of months, we'll come back and look at how to construct these things that we're doing with a compass and a straight edge, okay? And the reason why we're going to do the constructions is because on your end of course test, this will be something that you have to do yourself, okay? So let's get started here, and you have this paper laid out for you, and you've got a problem. The owner of Cedar Point would like to clean up the area between rides X, Y, and Z. Locate a point at which the owner should place a trash can to encourage a cleaner area. Now, let's boil this problem down to something real simple, okay? I want to know a point that's the same distance from X, Y, and Z. What point is the same distance between those three, okay? So, if we know a point that's the same distance between all three of those, hopefully we can... Lost my microphone. Here, we're back. Hopefully we can identify where to put that trash can. So, in looking at these points, if you guess, hopefully you went ahead and made a guess as to where that point will be. A lot of people put that point on the not the hypotenuse, but this longer side out here, okay? So let's go ahead and start to do a couple things that I'm going to help you figure out where it should be. Well, what I'm going to do first of all is I'm going to estimate where the middle of this line is going to be, okay, the midpoint right here. All right, and I'm going to make a mark here and a mark there just to show it's the midpoint. Now, yesterday we said if we go ahead and draw a perpendicular bisector in from this point, so if I have a straight edge, I'd probably want to use it right now. Okay, but that line right there, any point along that line, remember, is going to be the same distance from X as it is from Y. So if I'm down here, same distance from X as it is from Y. So as of right now, if your point that you estimated is the same distance from all 3 points, it should be somewhere along this line right here, okay? So that's something that we should probably put into play. Now, if I go over here to this side and I estimate my center point, okay, my midpoint, and then I draw a perpendicular line in from there, let's see here, something like, let's see, like that right there. It looks fairly perpendicular, okay? Any point along this line is going to be the same distance from this point as is from this point. So if I choose this point right here, it's the same distance from Y as it is from Z. Now what's interesting is this point right here, if I make a dot on it, okay, what do we know about that point? Where the intersection of this perpendicular bisector meets the intersection of this perpendicular bisector. Well, this point right here is actually the same distance from X, Y, and Z. Since any point on this line is the same distance from these 2 points, and any point on this line is the same distance from these 2 points, then the combination, the point that brings those 2 lines together, has to be the same distance from all 3 points. So what I would probably do is make a little note to myself, equidistant from points X, Y, and Z. Okay, my cursive Z, I probably should have done that. Z. All right. Now this point actually has a name, and this is what I was just talking about a moment ago. That name is called the circumcenter. Okay, the circumcenter of the circle. And so let's make a little note of that. Circumcenter. Circumcenter. All right. Now, what's also interesting is that if I go ahead and find the midpoint of this long side here, the XZ side, let's say it's going to be right about right there, okay? What's interesting about this is that the perpendicular bisector of that side will also pass through this same point right here. I know I didn't draw it very accurately there, but it'll pass through that same point. So in geometry, we call 3 or more lines that intersect at a point, we call them concurrent. Okay, so all 3 of those lines come together at a point, they're concurrent at a point, and that point is called the circumcenter. Okay, now, and so that's where you'd want to put that trash can. That would be the same distance from all 3 of these rides right there. Now, you may argue, okay, if those are the 3 rides in the area, the trash can seems a little out of the way because it's not going to be in a heavily trafficked area. And that's true. You know, realistically, if you wanted it in more of a heavily trafficked area, you'd probably put it more in this area right in here. Okay? But at the same time, I'm definitely closer to Y than I am X or Z in that case. And so I'm just trying to show you a point that would be the same distance from all 3 of those points right there. So from there, let me just show you a quick little video that I made up of the construction that we will be doing later on this year. And this is the part where I think it's kind of cool. When you can do something accurately and it ends up showing us a point that we're looking for. So here comes the video. Initially you'll see the new terminology, concurrent lines. So there you go, concurrent lines. 3 or more lines that intersect at one point, or in one point, okay? And then the point of concurrency is the point at which the 3 or more lines intersect. So it's where they come together. All right, so let me explain what's going to happen here with this video. A construction is anything that you do with a compass and a straight edge. And so right now I've got my compass. I stretched it a certain length. And all of these points right here along this arc are the same distance from this point. Notice I kept the same compass measurement. I didn't make the compass smaller or bigger, but I'm going to make an arc that all of these points on this arc are all the same distance from this point. And so what do we know about the intersection of the 2 arcs? Those 2 points right there are not only the same distance from this point, but it's also the same distance from that point. And so as a result, I can put in a line that connects those 2 points, and this line right here is considered the perpendicular bisector because 2 of those points are the same distance from the endpoints. So therefore, any of these points, if I go to this point right here, I think you can visibly see the distance there would be the same as the distance there. Okay? So I'm going to repeat that process. And again, if that was a little fast, you can go back and look that over again. But again, you don't have to know how to do the construction right now. We'll talk about that probably in January or February of this year. Okay? So I'm going to repeat that same process for the other 2 sides and draw in the perpendicular bisector. So I've got the one perpendicular bisector here now, okay? And so right here should be where the circumcenter is. So I'm just going to double check it to make sure I've done it correctly by doing the other perpendicular bisector. Okay, so as we move this along, oh, I went too fast probably. Right there, and we see, you can see they all meet at that point right there, called the circumcenter. Now what I did was I got rid of all those arcs, and I'm going to go ahead and I stretched my compass to one vertex right here, and we can see right now that this polygon, this triangle, is inside this circle. Now, I want to make this a little bit bigger for a quick second. And pause. Okay. Now, like I said before, this point is called the circumcenter. Okay. This circle on the outside is circumscribed. So I need you to think in your minds, circumcenter used to circumscribe. When a figure is on the outside, think circumscribe. Okay. Yeah, and I think you can read down there at the bottom, The point of concurrency where the perpendicular bisectors meet is called the circumcenter. The circumcenter is used to circumscribe a circle about a figure. Okay, so those are the three things I need you to remember, because that's going to be important when we get to our chapter test. Okay? All right, now, the next thing we're going to do, let's go back to the worksheet here. And so the big question right now is probably, well, what are you going to ask of me? How am I supposed to use this circumcenter stuff? And so as I look at numbers 1 through 4 here, your book is very generous to you when you're talking about finding the circumcenter, because 9 times out of 10 you're going to be asked to do it within a right triangle. So as I'm going to make this a little bit bigger so I can see everything. I'm going to label these points A, B, and C. And if we go ahead and graph those, A is here at 0, 0. Okay, B is at -8, 0. So here's B, -8, 0. And C is at 0, 6. So 1, 2, 3, 4, 5, 6. Okay. And so if I go ahead and connect these with my straight edge, okay. Actually, let me put this down, 0, 6. Okay. We need to go ahead and figure out where the circumcenter will lie. Now remember, from the previous problem that we did just freehand, we said we found the midpoint first and did the perpendicular bisector from there. So the midpoint between 0 and -8 is going to be -4. 1, 2, 3, 4, right there. Okay. And I'm going to do a perpendicular bisector through that point. Sweet. All right. Perpendicular bisector. Okay. Now, I'm going to do the same thing from the other leg over here. So if I do the midpoint between 0 and 6, I'm going to do 3. 1, 2, 3. Midpoint. Perpendicular bisector. Okay. And that point right there is considered my circumcenter. Circumcenter. Okay. Now from there, that point actually has an ordered pair of -4, +3. So I'll write that down. -4, +3. So that's one way you can find the circumcenter of a right triangle. Do the perpendicular bisectors of the two legs. Real simple stuff. Okay. Now the other way to find the circumcenter of a right triangle is to actually do something we talked about the other day. Your midpoint formula: x sub 2 plus x sub 1 over 2, and y sub 2 plus y sub 1 over 2. Okay, so in a right triangle, the circumcenter lies at the midpoint of the hypotenuse, and we'll just go ahead and prove that right here. We'll do x sub 1, y sub 1, x sub 2, y sub 2. Okay, so let's see here. Oh, if I go ahead and do this, that would be -8 plus 0 over 2. And then that would be 0 plus 6 over 2. Okay? We're looking at -4, 3 is that point right there. All right? And so you can do it one of two ways. Like I said, midpoint of the hypotenuse or the perpendicular bisectors of the two legs. So what I'd like you to do is I'd like you to pause your computer, because most people were able to do at least 2 and 3. 4 gets a little tricky, but if you think about what I just said, you can go ahead and do that. But pause your computer right now. See if you can find the circumcenters of those 3 triangles. Okay? All right, so hopefully you've at least given 2 and 3 a shot, maybe even number 4. So if I can go ahead and find the perpendicular bisector this side, the midpoint between 0 and -4 would be -2. So I do a perpendicular line there. Midpoint between 0 and 4 would be 2. Okay? And on this one, I would just go ahead and graph it out. -2, 2. Now, if you want to double check it, you can do the midpoint of the hypotenuse, okay? But that's where it's going to be. For number 3, -4 to 4, the midpoint would be 0. So right there. From 0 to 8, the midpoint will be 4. And so right here at 4, 0, that's what we're looking for the circumcenter there, okay? Now the last one's a little bit more tricky in the fact that the legs, they're kind of at a diagonal here. Okay, probably the midpoint's somewhere in there, right? And then you have to do the perpendicular lines. But let me just show you an easy way to do it. This right here is the hypotenuse, and it goes from -3 to +3. So the midpoint would be halfway in between, and if you had down 0, 0, that would be your circumcenter, okay? So that's how you would calculate the circumcenter of any of those problems there, guys. Now, I'd like you to go to the back side of your paper real quickly with me, and I want to look at the very last problem, and then we'll come back to the second to last problem. The second to last problem is actually a really, it's fairly complicated, okay? And so what I want to look at here, I use Mrs. Greiner. Mrs. Greiner is going to install a new triangular countertop in her classroom. She would like to find the center of the countertop so that she can put a stove in that would easily be accessible from all sides of the countertop. Okay, I probably should have a stove top in. If the triangle below is a top side view of the countertop, identify where she would put the center of the stove. Okay. Well, here's what we're going to do. If you go ahead and pull out a protractor here, and we're going to measure each of these angles. So if I go down and measure this angle right here, okay, that angle measurement looks like 55 degrees, and I want you to bisect that angle measurement. Okay, so if I go ahead and bisect that 55 degrees, we're looking at 27.5, 26, 27, and I'll put it right, did that make it? Right about right there. I'm trying to be as accurate as possible. I don't know if I can draw a line with this protractor. We'll see here. Can I do it? Suppose I should have figured this out beforehand. Nope, I cannot. Okay, well, we'll undo that last part. And we'll go ahead and get a straight edge out. Okay, and I'll connect those 2 points together. So again, what have I just done? I've done the angle bisector here. Okay, now remember, any point, like we talked yesterday, any point along this angle bisector has to be the same distance from this side of the angle as this side of the angle. I use the baseball property where you've got the first baseline and the third baseline, and second base lies on the angle bisector. How do we know? Because it's the same distance from first and third bases. And so, again, anything on this angle bisector is the same distance from the sides of the angle. Now, I'm going to go over to the other angle. Place my point right there, and what are we looking at there? 60. Get more down on the angle there. There we go. Looking at 69 degrees. Okay, so we're looking at 34.5 degrees for our angle. Get it in there. Maybe a little bit further, somewhere in there. Okay. And I'm going to go ahead and graph this angle here. Angle bisector. Okay, so again, this angle bisector goes there. Okay. So the thought process I want you to go through is, if any point on this line, this bisector, is the same distance from this line as it is from this line, and any point on this angle bisector is the same distance from this line as it is from this line, then what do we know about this point right here? Okay, and I'm actually going to go ahead and label these 3 points here so we have points of reference. Okay, Well, we know that this point right here has to be the same distance from this side here, and this side right here. Okay, and again, as you probably are wondering, does it have a name, a title? And it does. Okay, so let's go ahead and put this down. Equidistant from AB, BC, and AC. Okay, it's equidistant from all three sides right there. Now, if I go ahead and draw in the last angle bisector, let's see how accurate I was here. Let's see here, we have, okay, looks like 56 degrees, so 28 degrees would be out in there, okay? And so if I go ahead and draw that in, what we should see here in a second is that these three lines are going to be concurrent. They're going to come together at the same point, okay? And so that point, again, has a name. It is called the Incenter. Let's spell that wrong. Incenter. Okay, so the Incenter is used to inscribe. You remember a couple minutes ago I said Circumcenter is a key term that we're going to be looking at in this chapter. The Incenter is used to inscribe. Circumcenter is used to circumscribe. So the thought process I want you to go through over the next couple of days as you consider this, if you're a flashcard type person, is to make up flashcards. Perpendicular bisectors form the circumcenter, which is used to circumscribe. Angle bisectors form the incenter, which is used to inscribe. And just get that stuck in your mind, because if you can visually see those things, you'll be doing pretty good. Now, again, I want to show you another quick video here of how all this comes together and show you what it looks like to inscribe something. Okay? So, taking a look at, hopefully this pops up for me. There we go. What I'm showing you here as we work through this is just how I bisected the angles. So we have a 70-degree angle. I put down 35 degrees there. I've got a 50-degree angle, so I'm showing 25 degrees there. And I've got a 60-degree angle, and I show 30 degrees there. So again, that's the incenter right there. Now, to inscribe, I'm going to use that point, I'm going to stretch it to one of the sides with my compass. So if I do that, and I rotate this, it makes a very, very nice circle on the inside there. Okay, same distance from all three lengths. Okay, and so now we know where to put the center of the stove so that it is easily accessible from all three sides of the triangle. Okay? All right, now, with that being said, this next part that I'm about to show you is more or less a bonus. And so you can listen to it if you want to. If you don't want to listen to it, I understand, because there's a lot of deeper math. It's kind of cool to say, hey, I understood what he did right there. But if you don't, if you get going here and you're like, man, I'm not understanding this, understand, I won't ask this as a normal question. If I do ask it, it'll be as a bonus on a test. But basically, I want to make sure that we're understanding the connection to a lot of things that you did last year in algebra, to the coordinate plane, and now we're going to see this year with these terms. So I'm going to do this as quickly as possible. Again, this is something that you can go back and look at and make sure you understand. So, all right, so we've got 3 points here: 3, -4, 5, 6, and -3, 4. So 3, 1, 2, 3, 4. Okay, that point there, that is A. B is going to be at 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And C is at -3. 1, 2, 3, 4. All right, now what we're going to attempt to do here over the next couple of minutes is go ahead and show the perpendicular bisectors of at least two sides. Okay, we don't need to do all three sides because with two sides, you already know where the circumcenter will lie. What makes this problem hard or harder than the others that we already looked at is it's not a right triangle. Okay, this is more or less a looks like a scalene triangle to me. Could be isosceles, but it looks like a scalene triangle. So if we go ahead and work this out, remember the first thing that we did from the previous couple of problems we did with the circumcenter was to find the midpoint. And so if I go ahead and find the midpoint between AB, okay, of AB, you can use your midpoint formula, or I can do half the rise and half the run. So if I go up here, the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The run is 2. So I can go halfway up, 1, 2, 3, 4, 5, and over 1. And that point right there is going to be, I'm going to label it point D, is going to be my midpoint of AB. And you can look at it, it looks like the midpoint. So that is over 4 and up 1. Okay, if I do the same thing, let's say I'm going to find the midpoint of AC. Up 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So I'll go up 4, 1, 2, 3, 4 over 3, 1, 2, 3. That point right there is going to be my midpoint of that side. E, 0, 0. Okay. All right. Now from here, I'm going to go ahead. I'm just going to get rid of this. I wrote that on the graph. I'm going to go ahead and figure out a line perpendicular to AB and then construct that or put that in from point D. Okay. So if I go ahead and do the slope of AB, 1, 2, 3, 4, 5 over 1. So the slope of AB is going to be a positive 5 over 1. Well, we talked earlier this year, the perpendicular slope of AB is going to be negative 1 over 5. Okay? So what I'm going to do from this point right here is I'm going to do that perpendicular slope. Positive 1, negative 5. 1, 2, 3, 4, 5. Right there. Okay? I'll put that as point F. Okay? And I'll go ahead and connect those two. So that line right there is the perpendicular bisector of AB. Okay? We're going to do the same thing from point E. So the slope of AC is a positive 4, or let's see here, 1, 2, 3, 4. Yeah, positive 4, negative 3. So the slope of AC is a negative 4/3. So the perpendicular slope of AC is going to be a positive 3/4. Okay, I'll put that out. Positive 3/4. 1, 2, 3. 1, 2, 3, 4. E, F, and we'll make that point G. Okay. Now, everything so far looks like it's moving along really well until I get to this point right here. And what I mean by that is this. We want to find where the circumcenter is at. It's that point right there. The problem is it's not quite 2, and it's in between 1 and 2 on the y-axis. So I want to be exact. I want to know exactly where it crosses as far as the ordered pair. So how am I going to do that? Well, we're going to figure out the equation of these two lines. So, and then we're going to use them to work against each other. So the equation of the two lines, if I go ahead and start with, let's say EG. EG, we know point E is at 0, 0, and we know that the slope is a positive 3/4. Okay? So if I plug that into my point slope form, y minus the y value equals the slope x minus the x value. And we work this all out, distributing this, okay? All we're left with is this right here, okay? So that part was pretty simple. The other part is to go ahead and do the same thing for df. So df right now has d, which is at 4, 1, and the slope, which is at negative 1/5, okay? So if I plug this in, y minus the y value is equal to the slope x minus the x value, okay? Now, simple algebra, distribute the negative 1/5. Notice there that the double negatives become positive, and then I'm going to add 1 to this 4/5 over here. All right, now that's a little bit more complicated right there. We've got those fractions going on. So what am I going to do? I have to use these two equations against each other, and so what I'm going to do is substitution elimination. I already know that y equals this, so I'm going to take this and plug it in for the y over here. When I do that, I'm actually going to clear this off so that we can see everything a little bit better. Let's do this. Yeah, we'll just do that. Don't forget those equations. Hopefully I don't forget those equations. Okay, so the one equation was y equals 3/4 x, and the other equation was y equals negative 1/5 x plus 1 4/5. Okay? So if I go ahead and plug in the 3/4 x for this y over here, bringing those two equations together, okay, one thing we could do is multiply everything by a number that 4 and 5 both go into, so that we can go ahead and get rid of those fractions. So, one second here. Alright, so if we go ahead and multiply everything by 20, we end up with 3/4 of 20 is going to be 15. 1/5 of 20 is going to be 4. Okay, and 4/5 of 20 is going to be 16, and if we add 16 to the 20 there, we get 36. Okay. Now, if I go ahead and solve for x, adding 4x to both sides, and then dividing through by 19, we're going to get that right there, which is actually, let's see here, 1 and 17/19, almost 2. So I'm very pleased with that outcome for an x value. Over here at 1 and almost 2, that looks about right there, okay? Now what we should be looking for when we find the y value is something that's almost 1.5. It looks like it's up there close to 1.5, maybe just shy, so let's see how this works out. If I go ahead and plug, I'm going to use the improper fraction here because I can see everything a little bit better when I plug this into my equation up there. So y equals 3/4 of 36 over 19, okay? Now, a little trick here, I know 4 goes into 36 9 times. So what we're really looking at is, this becomes a 1. 3 times 9 is 27. 1 times 19 is 19. So this ends up being 1 and 8/19. Okay, and if we think about that, 19 divided by 2 is going to be 9.5. So yeah, just slightly less than 1.5. So again, the ordered pair of this value right here is going to be this. The x value is 1 and 17/19, and then 1 and 8/19. Okay. Now again, why do I like that problem? It's a lot of stuff that you guys have been studying over the last 2 years, all brought together in one single problem, and again, it's reinforcing what we're currently studying, the Circumcenter. So Again, I wouldn't give you that hard of a problem on a test unless it was a bonus, but I can probably say that there will probably be something similar to that as far as a bonus on one of your quiz or tests. So if you caught all that, that's awesome. If you didn't, you let me know, and maybe we can talk some things out that you didn't quite understand. I appreciate your time and attentiveness, and I wish you the best. Good night.